Algebra 1. So we've solved systems of equations graphically, by substitution, and finally by elimination. Okay, we'll continue on with elimination today, but now we need to think about we could use any method. Okay, some people like elimination because you can often avoid fractions by doing this. So this one is really clear. All I really need to do is add these equations. You get what? Negative 13y equals 23. So y is going to be negative 23 over 13. Okay, so I did get a fraction, but I didn't have to work with fractions. But I do have to work with fractions to figure out what x is. Okay, so 4x minus 7, negative 23 over 13 equals 13. To eliminate fractions from this equation, I could multiply by 13. So 4 times 13 is what, 52? So 52x. When I multiply this one by 13, I get rid of the 13. So minus 7, negative 23 equals 13 times 13. Okay. So 7 times 23 is a 1, carry the 2. So 161. So 52x plus 161 equals 169. 52x equals, what is that, 8. So x is 8 over 52, 4 over 26, 2 over 13. So x and y, your answer is 2/13, negative 23/13. Okay. So sometimes the fraction is just unavoidable, especially if the answer is both fractions. Look at solving this guy by graphing. Y minus x equals 1. So let's rewrite that equation. Y equals x plus 1. That makes it a little bit easier to graph. The y-intercept is 1, and the slope is 1. So that's a pretty straightforward guy. So forth. There, I should be able to insert that line. Like so. So this is y equals x plus 1. Now if I look at the next one, a couple ways of thinking about this. So if I solve this, the slope is going to be negative 1, but the y-intercept is a little bit off. But let's just go ahead and put it in y-intercept form. So what, 10y equals minus 10x plus 52, divide everything by 10. Y equals negative x plus, when you divide 52 by 10, you get 5.2. Okay. So the y-intercept is at 5.2. So 5.2 is somewhere right there. The slope is 1, so you're going to go down 1 over 1, so something like that. It's going to hit right there and there. So you see with this one, when I insert this line, it's clear that they intersect at one point, but on the blue line, this is the point, what, 2, 3? So the point 2, 3. But on the green line, if I put in a 2 and a 3, I get 50, not 52. So that's not quite it, okay? So I really can't get to this one graphically because they do not intersect at a grid line. So in this one, I'm going to use one of the other methods, okay? So graphical really only works if the answer is a nice integer, but you don't know the answer is a nice integer until you work the problem. So graphical is probably the most constraining or the least useful of the ones that we would do. So in this one, if I look at it, if I had to pick a method to choose, This is very easy to solve for y. I would use substitution for this guy. Okay, to use this for substitution, y is equal to x plus 1. So I would just have 10x plus 10, x plus 1 equals 52. So this is going to give me what? 20x plus 10 equals 52. 20x equals 42. X is 42 over 20, or 21 over 10. Okay. So 2 and 1/10. So it's clear that that wasn't 2 and 3. And then I could use that to solve for y. So if I think about it, what are the strengths of graphing? Okay. Graphing is, it's fairly easy. Okay. There's very little algebra involved, when you are graphing. Some of the weaknesses are, the biggest one, it doesn't always work. The other weakness is graphs are not always accurate. Graphing it depends on how neat you are and how nice the numbers are. So when do you use graphing? Really, you want to use it when you're, when your y-intercept is an integer, or mainly when the solution is integer. Anytime the solution doesn't lie on a grid line, it's going to be tough to use that one. What are some of the strengths of substitution? One of the strengths is that it always works. There can be one of the weaknesses, it can be a lot of algebra. We could call that a fun, not a weakness, okay? It's, when to use, this thing can be used anytime. When I look at it, I want to use it if I look at something and it's real easy to solve for one of the variables. So like if one of the coefficients, one variable coefficient is 1. If I see 1 as a coefficient, then, it's easy to solve for that variable. So substitution works. Elimination always works, okay? It can have, same thing, it can have a lot of algebra, When can I use this? If I will use this when I clearly see, when I see variables that cancel easily. Like if I had to multiply one equation by 12 and the other one by -13 to get it to happen, that feels complicated to me. But if I could double one equation and add it, then that feels easy, okay? The least algebraic method we have is graphing, okay? The most algebraic we have is substitution, because you have to algebraically solve for 2 variables. Elimination, one variable gets eliminated and you're basically solving for 1 variable. So these are sort of, they could run neck and neck for a tie for that. The least precise method is graphing. Most precise, these enter a tie. Elimination and substitution. These things sort of go hand in hand. Which methods do you need to know? We're going to go with all of them, okay? Let's look at this. Let's solve this by all 3 methods, okay? Let's start by substitution. So if I want to solve this by substitution, I need to solve one of these equations for one of the variables. There's not a real obvious choice, because if you look at the top equation, you divide by 2, you get fractions. Divide by 5, you get fractions. Same thing below. So I'm going to have fractions no matter what I do. So let's just pick, I'm going to pick the smallest fraction. So dividing by 2, So take that top equation, 2x equals negative 5y plus 3. So y is negative 5 halves x plus 3 halves. And I need to substitute that into the equation 3x minus 7y equals 10. So I'm going to have 3x minus 7 negative 5 halves x plus 3 halves equals 10. 3x, okay, plus 35 halves x minus 21 halves equals 10. Okay. And so if I think of this as going to be multiplied by 2 over 2, that's 6 over 2x. So I get 41 over 2x equals 10. I need a common denominator of 2 plus 21 over 2. So that's going to be 41 over 2. Okay. So 41 over 2x equals 41 over 2. So x is equal to 1. Now that's interesting. I did all that work. I couldn't avoid fractions, but I did get an integer value for x. Now to figure out y, go back to this equation right here. So y is going to be negative 5 halves times 1 plus 3 halves, which is what, negative 2 halves. So y is negative 1. Now elimination. So you've got 2x plus 5y equals 3. 3x minus 7y equals 10. So if I multiply the top equation by negative 3 and the bottom equation by 2, I'm going to get the x's to cancel. So that gives me negative 6x minus 15y equals negative 9. 6x minus 14y equals 20. Did I do that right? So 2x plus 5y equals 3. 3x minus 7y, so multiply by negative 3, I get the negative 6 and 6. So negative 15, negative 9, 6 minus 14 and 20. This goes away. Negative 29y equals 20 minus 9 is 11. So I did something wrong here. And my mistake was this was a negative 10, which makes this a negative 20, which makes this a negative 29. So y is equal to 1. And if I plug back in, I'm going to also, so if I get y is equal to, did I do that right? Oh, sorry, y is equal to 1. I thought, wait, hold on. This is one of the nice things about solving multiple methods. If you make a mistake, this thing was a negative 10. That was a negative 10. That was a negative 10. This was a negative, right? Negative 20. So 7y. And so y was negative 5 halves plus 3 halves. So when I substitute that in, 35 halves minus 21 halves. So it's going to be negative 20, so it's going to be 1 half. Let me back up. I've made a mistake. I'm going to back up and just redo this real quick. So let's redo this, figure out what mistake that I've made. Okay, so 2x plus 5y equal 3. So 2x plus 5y equals 3, and 3x minus 7y equal negative 10. 3x minus 7y equals negative 10. So take this equation and you get what? 2x equals negative 5y plus 3. X equals negative 5 halves y plus 3 halves. I think the problem is I substituted in for the wrong variable. This is my x value. So then take this equation, 3 times negative 5 halves y plus 3 halves minus 7y equals negative 10. Negative 15 halves y plus 9 halves minus 14 over 2y equals negative 10. So this gives me what? Negative 29 over 2y equals negative, I'm going to call that negative 20 over 2 minus 9 over 2. So negative 29 over 2y equals negative 29 over 2. Y is 1. Okay. If y is 1, plug that back in here. You get x is negative 5 halves plus 3 halves. So x is negative 1. So I had them mixed up. Now by elimination, 2x plus 5y equals 3. 3x minus 7y, negative 10. Multiply the top equation, we'll say by 3, the bottom one by negative 2. And then I get what? 6x plus 15y equals 9. Negative 6x plus 14y equals 20. So 29y equals 29. Y is 1. Substitute that back into, let's go to the bottom equation. So y is 1, so 3x minus 7 times 1 equals negative 10. 3x equal, add 7, negative 3. X is negative 1. Okay, so I got the same answer, so I know it's right. Now let's go to graphing. Okay, so if I look at this top equation, when x is 0, y is going to be 3/5. Okay, when y is 0, x is going to be 3/2. Okay, so that's one way of looking at that equation. So 0 3/5 is 0.6, somewhere right in there, and that's where I'm sort of guessing. And then 3/2 0 is 1.5. Okay, so I've got to connect those lines. Okay, I can plug in, say, another point. If I think about, if I plugged in, say, a 1 for y. So look at this equation. X and what we got, 2x plus 5y equals 3. Okay, if y is 1, let me do it this way. In that top equation, if y was 1, that would be a 5. So you would get 2x equals 3 minus 5. So 2x is equal to negative 2. So x is negative 1. So negative 1, 1. So negative 1, 1 is a point right there. So I can start to draw that line. Let me get out of that. I want to delete that. To draw this line, insert a line. So something like that. And if I try to extend that, there we go. Now, if I look at the next line, this guy right here, okay, so 3x minus 7y equals negative 10. So if x is 0, then y is 10 over 7, which is 1 3/7, so almost 1.5, okay? If y is 0, so if y is 0, x is negative 10/3, negative 3 1/3, okay? So negative 3 1/3, 1, 2, 3, negative 3 1/3, 0, so somewhere right there, and 0, 1 3/7, so 0, the other guy was at what, 3/5, so 1 3/7 is somewhere right in here. Okay, so if I try to insert the line there, something like this. There we go. So try to make that line a little bit longer. I didn't mean for that guy to move around. There we go. So all of that work, and I feel like the answer is negative 1, 1. Okay, so I avoided a whole lot of algebra, but I had to go to a lot of level of detail to get the answer. So you can see why we do prefer the algebraic methods. Okay, so what I want you to do now is just you spend time solving these by any method. Okay, so you need to be able to do all methods. So don't just say I'm doing all elimination or all substitution, or all graphing. So try to mix them up. Okay, it's okay. I put graphs there so you don't have to graph them all, but just look at these and figure out that you're comfortable with doing the multiple methods. Okay.